Hey everyone, this is Miss Valentine, and you are watching the Greenhouse Effect and Global Warming Notes. I wanted to point out the structure of our notes packet for this week because it's a little different than we usually do. This is actually a set of notes that I used when I worked in California, and this type of note taking called Cornell style notes. It was really popular there, or it was when I taught there. So, what it is on the left here, you'll see some questions, and then the questions are going to be answered on the right side. So you don't need to fill in any information on this left column. These questions are meant to be answered on the right side. So just a quick explanation of that before we get started. All right, so the greenhouse effect and global warming are two terms that you might hear together, but they are different things, and we'll talk about exactly why they are different. And then there's the phrase climate change as well, which will come in at the end of this presentation. That is also mixed into the same conversation, so let's kind of sort through what some of these terms mean. And as you see in this picture here, we have a polar bear painting one of his friends into a panda bear. And I normally ask students in class, like, why is that? But since this is a video, I'll kind of phrase it for you. The panda is in a more warm region of the earth and therefore more likely to survive in terms of natural selection, as we are seeing the polar regions where the polar bear lives becoming destroyed as a result of melting ice. So polar bears are much less likely to survive our current climate change than panda bears, which live in a warmer climate. So that's the reason behind the image here. So take a look here at this picture. If you've ever been inside a greenhouse, you know that it's incredibly warm, and it's also used to grow plants. So that kind of gives us an idea of what the greenhouse effect actually is, and how a greenhouse work kind of is how the earth works, or it is how the earth works in terms of the greenhouse effect. So in a greenhouse, sunlight enters the glass walls and it gets trapped in. That creates a warm atmosphere so that the plants can flourish. Now, the greenhouse, this glass trapping of heat, was discovered centuries and centuries ago. They realized that if you have large glass windows and sunlight comes in, it keeps the heat inside. So having glass windows, having glass walls, that has actually been a technology that we've used for hundreds and hundreds of years now to help keep the inside of buildings warm. And so that is why your car windows are trapping heat on a sunny day. So if even in the middle of the winter, if you get into your car and it's been sunny out, it's warm inside your car because of this greenhouse effect, essentially is what it is. So this similar effect happens with our Earth as well. If you think of the gases in the atmosphere, like the glass on your car or the glass in a greenhouse, those gases trap the heat on the surface of the earth. And I believe this might be similar to the picture that you have on your notes packet. But this is called the greenhouse effect, and that's because essentially is a greenhouse. The earth is a greenhouse where the gases are trapping the heat on earth. So it has the effect of a greenhouse. So what is the greenhouse effect? The official definition would be the heating of Earth's surface and the atmosphere from solar radiation, so from the sun. And that solar radiation, or that heat from the sun, is being absorbed or taken in and then emitted or given off by gases in the atmosphere. So you have this trapping of the heat, trapping of the solar radiation by the gases in the atmosphere. So it's taking the heat in and then releasing it over and over again, and that creates kind of a warming, blanketing effect around the Earth. And so that is the official definition of the greenhouse effect. But to put it into simpler terms, the greenhouse effect is where gases in our atmosphere act like the windows on a greenhouse, and they trap in the sun's heat. I'll give you a moment to finish copying that down. So just like the glass on a greenhouse, sunlight goes through these gases, and those gases help trap the heat inside. Here's a picture from your notes of the greenhouse effect. You can see the sunlight comes in, It bounces off the earth. Some of it is even absorbed by the gases on the way in. About half of it is actually reflected back out into space, but a lot of it is trapped by these gases close to the surface of the earth. So you can see, just imagine this as a layer of glass around a greenhouse, and that when the sunlight comes in, it stays inside and keeps the plants warm. So in the same way, these gases are keeping our earth warm because they are trapping that heat. All right, so here we are at our first pit stop. Where does the greenhouse effect get its name? Why is it called that? Go ahead and pause the video for a moment while you answer the question. So what are greenhouse gases? The basic definition is just gases that trap heat. And there are a number of different types of greenhouse gases. Other gases in the atmosphere that don't trap heat are nitrogen, oxygen. So you have lots of gases in the atmosphere that don't trap the heat, but you also have these greenhouse gases present in very small amounts, actually. So the greenhouse gases make up a very small proportion of the atmosphere, yet they have a huge impact on the amount of heat that gets trapped in the atmosphere and on the surface of the earth. So the main types, I will say that these are just 4 of the top greenhouse gases, not the only greenhouse gases that there are. Carbon dioxide is the one that we hear about the most. We'll talk a little bit more about why that is. Water is, surprise, surprise, is a very potent greenhouse gas, a very strong greenhouse gas. So water is a top greenhouse gas in our atmosphere. Methane is one that we are increasingly concerned about as a contributor to global warming, and we'll talk more about where that comes from. And then CFCs, or chlorofluorocarbons, so chlorine, fluorine, and carbon molecules. Those are actually associated not only with warming up the atmosphere, but they are also associated with destroying the ozone layer. So that is both a greenhouse gas and an ozone destroying chemical as well. So those 4 greenhouse gases are the top types of gases in the atmosphere that trap heat. And like I said, they form a rather small percentage, or at least carbon dioxide, methane, and CFCs form a small percentage of our atmosphere. There is quite a bit of water vapor. And again, we'll talk a little bit more about that in a few slides here. So the greenhouse effect is actually a good thing. So when you hear that word greenhouse effect, sometimes it's associated with global warming and climate change, which it is, but it is a good thing on a global scale when we're thinking about the Earth itself. It keeps the atmosphere about 60 degrees Fahrenheit warmer on average than it would be without it. So just kind of imagine the Earth with a temperature that is 60 degrees Fahrenheit cooler than it is right now. And I'm talking about an average global temperature. We would have an ice ball Earth. Essentially, life would not have evolved on Earth if we didn't have this greenhouse effect. You need warmer climates, you need liquid water specifically to have life evolve on Earth. And so if we hadn't had the greenhouse effect, if that was not part of our Earth, then we would have never evolved, and most life forms probably would not have evolved either. So it's actually a good thing for the Earth. The problem for us as humans is that we have built our society in such a way that we live on these coastlines in a very narrow temperature range that is good for us. But now that things are changing, that change in temperature is too much for us, for our species, for us at this time. But anyway, I mean, it is a good thing because life would not have evolved without the greenhouse effect. So that gets to our next pit stop question here. What would happen if we didn't have the greenhouse effect? So you can be specific with numbers if you'd like, or you could be more general. What would some of the effects of no greenhouse effect be? So go ahead and pause the video while you answer this question. So how do we get these greenhouse gases in our atmosphere? Carbon dioxide, the one that we hear most commonly, is unnaturally put into the atmosphere by the burning of fossil fuels. If you think of all living things having carbon in them, we talked about that last semester, all that carbon in those living things, not just us, but in like small microscopic organisms, gets buried and turned into fossil fuels. And once we burn those fossil fuels, it just releases that carbon from those organisms, those dead organisms, back out into the atmosphere. So that's the natural, or I'm sorry, the unnatural way that we get carbon dioxide. The natural way was through volcanic eruptions. So in the past, when we have these warming periods, you generally saw a lot of volcanic eruptions as well, because those were volcanic eruptions were putting more carbon dioxide in the atmosphere, and that made it warmer at those time periods. It caused it to warm up. Now we are unnaturally causing it to warm up much faster. And that's part of our problem with climate change and global warming right now. Methane is actually a very potent greenhouse gas. It comes from livestock emissions, cow farts and cow burps. And even like we also put out methane as well in those same ways. Manure or livestock waste, that will all contribute to methane emissions. But we are also seeing a lot of methane being released from permafrost that is melting in the Arctic. So as it gets warmer and this permafrost melts, all the methane gas that was trapped in that permafrost is now being released into the atmosphere. So that's just increasing the warming effect of that greenhouse gas. CFCs, or chlorofluorocarbons, those used to be used as a propellant or something to cause the spray to come out of a spray bottle. So like, think hairspray. If you burn plastic or burn foam, you're releasing CFCs. And then refrigerants for air conditioning and for coolers, refrigerators, that also releases CFCs, although we have changed our refrigerants in the past 20 or 30 years because of problems with the hole in the ozone layer. We've changed it so that we use something called HCFCs, and I think they're even changing from that because that causes environmental damage as well. But these CFCs that used to be used in the US, they're still used in other parts of the world, are also greenhouse gases. And then water vapor, which is really just clouds or fog in the atmosphere. And oftentimes you don't even see the water vapor. So there's water vapor in the room right now that you probably just don't, obviously you can't see it. You can see it when it's fog because there's so much water in the atmosphere. And this is actually one of the more significant greenhouse gases. This one has the greatest effect on the greenhouse effect, but it's such a normal effect, having all this water in our atmosphere, that we're just used to it. It doesn't actually change from a global scale. It's not going to change from over hundreds and thousands of years, the way that carbon dioxide and methane do. Those, even though they're a small percentage of the atmosphere, they make a huge difference. Water vapor has always been here. So I shouldn't say always, but it has been here for many hundreds of thousands of years. So when you go outside at night and it's clear outside, more likely it's going to be a little bit cooler and more crisp because you don't have the clouds trapping in the heat from the surface. Now, if you go out on a cloudy night, especially in the winter, it will feel a lot warmer than it would on a clear night. So that water vapor is trapping the heat. Also, if you burn or use humidifiers in your house, or even if you're boiling and cooking with steam in your kitchen, you will feel a lot warmer because that water vapor is helping to trap the heat from the air around you. So water vapor is actually the most significant impact of the greenhouse effect. And here we are at another pit stop. What are some ways that carbon dioxide is released in the atmosphere? And remember, there is an unnatural way and a natural way that it is released into the atmosphere. Go ahead and pause the video while you answer this question. And we have one more pit stop for this one. Why does it feel warmer on a cloudy night than on a clear night? What greenhouse gas in the atmosphere causes that to happen? Again, pause the video while you answer this question. All right, so we have talked about the greenhouse effect, how it's a natural thing, how our Earth would not be the way it is without it. We wouldn't have liquid water without a greenhouse effect. But too much greenhouse effect is bad for us at the moment. Again, the way that we have built our human settlements and the ecosystems around us have built themselves up, it's bad for us to have too much heat. So the greenhouse gases that continue to be added to the atmosphere create more heat being trapped by the Earth. So it's like making your blanket thicker. So this is what leads to global warming. Now, global warming is a result, again, of that thickening of the greenhouse gases, the thickening of the blanket. Global cooling is another thing that can happen when you take away those gases. So this is a natural process that we are just making happen a lot faster by adding greenhouse gases to the atmosphere. So what is the official definition of global warming? It's an increase in the average temperatures of the Earth. So we're talking about over the entire surface of the Earth, over an annual temperature is usually what they do over the course of a year. So it's the average increase in temperatures of the Earth and the atmosphere, due in part to greenhouse gas levels. So like we watched in the video on how Earth's climate history has changed over time, there are other cycles that influence changing temperature on the Earth. Those are either a very small impact, like sun cycles is like 0.1% of an impact on the Earth, versus the 100,000 year cycle of the orbital pattern of the Earth around the sun, meaning it changes from being a circle to being an oval, and that has a dramatic impact as well. So that's what it means by in part due to increased greenhouse gas levels. However, these greenhouse gas levels have had the most significant impact in our human history in the last 12,000 years or so, and especially in the last 250 since the Industrial Revolution. So the effects of global warming are that we see these increased carbon dioxide levels, as well as other greenhouse gases. Methane is another one that we're becoming more and more aware of as a factor. Those have caused an increase in global temperature. So once again, these gases, carbon dioxide and methane, CFCs, they make up a very small proportion of our atmosphere. However, they have a very significant effect when it comes to raising the global average temperatures. So that is the initial effect. You just have this increasing overall global temperature increase. As a result of that, you have the temperatures of the sea rising. So water, if you remember from physical science or chemistry class or whichever class you took, when you take water and you boil it, it goes from being a liquid to a gas, and it's actually causing the molecules to expand. So warm water expanding is the main reason why sea level rises. It's not adding ice to the ocean, although that does have some effect for sure in raising the sea level. It has more to do with the warming of that water, which causes it to expand. You also have an increase in evaporation caused by warmer temperatures. When you evaporate more water, you have more water vapor in the air. And if you remember, water vapor is a greenhouse gas itself. So it just makes the problem even worse. So you're creating more greenhouse effect by having more water vapor in the atmosphere. Also, as a result of more water vapor in the atmosphere, you have more violent hurricanes, more rain, more storms. And so we're starting to see all of these things happening with global hurricane numbers and global disasters in those as a result of that increased evaporation of water. So climate change is the term that you hear more often now. It used to be global warming, but I think they changed the term because it's really climate change that is what we're worried about, what causes all of the environmental disasters that we're seeing. So global warming leads to climate change, or global warming causes climate change, which global cooling would also cause climate change. So climate change is just basically a change in the global or regional climate patterns, and it can be caused by global warming or by global cooling. Right now, what we're seeing is global warming because of our adding of greenhouse gases to the atmosphere. And just keep in mind that global warming or climate change involves extremes in both directions, both warm and cold, both dry and wet. So we see some regions that are a lot drier right now, like out west in California. We see some regions that are much wetter. The southeast, even around here, we've been getting a lot more rainfall than we have historically gotten in this area. So you're seeing a lot more flooding in some regions. You also see both warm and cold extremes. So some climates will become more cold, some climates will become more warm. So just because it's global warming, the overall average temperature is increasing. What that means for specific areas depends on the area. So, but it's changing in either direction, extremes in weather and temperature in either direction. So here is our final pit stop. How are global warming and climate change related? And I tried to give you a sentence starter here that will get you going. So global warming, blank, climate change. Maybe incorporate that into your answer. Go ahead and pause the video while you answer the question. All right, so here we are at our summary section. Make sure you do your 5-sentence summary at the end. Read through your notes again before you write your summary. And take a look at this damn rainbow. Quite a pretty picture there. If you have any questions, feel free to reach out to me and let me know. We will continue to study global warming, climate change, and the greenhouse effect throughout this chapter. So it is an important topic, especially relevant to our current political and economic climate. We also will talk about energy in the next unit and how energy plays a huge role in climate change and in global warming.